Good morning, friends. How's everybody doing? Two videos today, so that means you get the pleasure of having two jokes. Lucky you. What do you call a bear with no socks? You call him barefoot. All right. Um, the first thing I want to show you is I'm going to present my screen because I'd like to show you a PhET simulation. We've done these before, but what I've got set up for you here is a series circuit. Okay, now how do I know it's a series circuit? Because all the current makes one loop. So if I show the current, you will see, hopefully, that the current is moving. It's just moving very slowly, I guess, right now. You can see all of the electrons that are moving. Okay, the second thing I wanted to show you is that each one of these resistors has a different value. And how do I know that it has a different value is because it has different colored bands. So if you were working out in the real world and you saw resistors with different colored bands, each one of those bands means something. Now there's a code that tells you when you have brown, black, black versus red, black, black versus yellow, black, black, what does that mean? But for our purposes, we don't really need that. So I'm just going to turn on the values, okay? And we'll go back to showing that moving current. Now, the interesting thing about a series circuit is that I can measure the current. Now, this is an ammeter that's made just for this particular simulation. So this isn't what real ammeters look like. Okay, but if I take and I place the ammeter here, you will see that the current is 0.15 amps. If I take and I move the ammeter over here, you see the current is 0.15 amps. If I measure the current over here, it's 0.15 amps. Hopefully you're getting the picture here that the way a series circuit works is that the current is the same throughout. So no matter where you measure the current is the same, which is helpful for us. Okay. Now the same is not true about the voltage. So let's go ahead and measure the voltage. I'm going to drag out my voltmeter. Okay. Remember I said voltmeters are huggers. So you can sort of see the two arms on a voltmeter. And this is what a voltmeter looks like in real life. Okay, so if I go ahead and hug the battery, it should be no surprise that it reads 9 volts because this is a 9-volt battery. Okay, now what happens if I hugged in the opposite direction? Okay, you would see that it measures negative 9 volts. Okay, so it doesn't really matter the sign for the voltage. We're just going to go ahead and measure the voltage. Now, if I take and I measure the voltage here, I hug this resistor. Oh, geez, I put it the wrong way. Let me rearrange. Okay, I get 1.5 volts. So our smallest resistor is at 1.5 volts. If I go ahead and measure over here, over this next largest resistor, I see that when the resistance increases, the voltage increases also. Okay, so this one is 3 volts. Now here's our largest resistor. Let's see what we get here. 4.5 volts. Okay, so again, as the voltage increases, the resistance as the resistance increases, the voltage increases as well. And if you remember, this was 1.5, this one was 3, and this one was 4.5. If you take 1.5 plus 3 plus 4.5, okay, that gives you 9. So the way it works in a series circuit also is that the voltage of this resistor plus the voltage of this resistor plus the voltage of this resistor gives you the total voltage or the voltage given off by the battery. What if you had 57 resistors in here? Well, if you added all their voltage up, it would give you the voltage of the battery. Okay. I'll see you in a few minutes to take some notes. Thanks, guys.